Okay. Good afternoon, everyone. Welcome to second lecture, Software System Requirements and Design. How is it going? Everything is good? Any concerns, comments regarding contents, lecture recordings, Canvas site? No issues at all? It's good to hear that. Okay. So, in today's lecture, we will talk about agile software engineering. But before going to the lecture's content, I just want to update you that SAP is now, not SAP, sorry, SAM, which is basically Statement of Assessments. It's available on the Canvas site, and you can view it. And you can see that it has quizzes. Previously, it was some sort of reflection that students are required to submit. So I have changed it to quizzes. And first quiz, I will let you know by announcement, would be in week 3. And it would be open-ended questions, maybe 8 to 10 questions, short, brief, to the point. Okay? And I would allow maybe 30 or 45 or maybe 1 hour for a student to attempt that quiz in that session. Okay? So I will provide you more information hopefully early next week. And I will open the quiz maybe on Thursday and Friday, 2 days for you to attempt it. I will keep you posted. Another thing which I changed over here, previously these two were hurdle task. Okay, I have removed that hurdle task, so you have to pass the course, you just need to get the required marks. So these are now more hurdle tasks, okay? Okay, let's recap. What did we covered in the first lecture? So just help me to recall, what concepts did we cover? Anyone? What did we cover? Yes? We discussed about system. We try to understand what is a system and what are the components that are related to it, with each other to realize that system. And in this week workshop, you will see that those components would have certain processes involved. Those would have certain inputs and outputs. So system is one of the core entity which software engineers basically work for, and so on. Okay? We discussed about systems. It consists of integrated components. And we discussed about the context software engineers are working. And in that context, we discussed there is a customer for whom you have to gather the requirements and you have to build the system. But the real challenge that brings into this context was the environment. The environment is changing. And that environment basically put pressure on software engineer to predict how the system would look like in the future. And in today's lecture, we will build on top of that. And we discussed waterfall model. Who can recall what is waterfall model? Very briefly. Yep, go ahead. Waterfall model? Keep on sitting, yeah, that's fine. Okay, so it's a plan driven where requirements are predefined. So you first define the requirements, then go to analysis, then go to design, implementation, and deployment. So we also discussed that. And increment development, we saw that it takes a different approach. It takes building of software in increments. We are not looking at building the software in one go, rather we are building in increments. And in today's lecture, we will build on top of it. So if you don't have any question from the previous lecture contents, then we can move forward. So this is agenda for today's lecture. You can see that in today's lecture, I will try to now establish about the challenges that software engineers faced. And in this lecture, we will see how they have been addressed to some extent using agile software engineering development method. So some systems we will see and the issues with them. Then we will build our understanding what is agile software engineering, what are their manifesto, what are the development methodologies, and so on. And for development methodologies, we will look at them. I will go to first to a little bit detail, and then we build on this. And then a case study in which we will see that if agile methodology is being applied, how those activities would be performed. Okay. So in software development, as we discussed in the last lecture as well, that budget and time. These are the two constraints on software development. Like in civil engineering, they are constrained when you build a house. You have certain cost and you have certain time period to build in, and those constraints are the one which you let know to the architect, and architect basically and the constructor who has to construct the house, they work in those constraints. Similarly, in software engineering, we have those constraints, and historically, software engineer basically the projects, they go over budget and they go over time. Okay, so this is one problem. Second is the environment is changing so rapidly. There's so much demand by the customer that the software engineer, they are not able to pace up with, and they need more tool support so that they can automate the process. So changes are coming rapidly, and softwares are not able to address them in timely fashion. And as a result of those constraints, the quality is getting affected. If you recall the triangle we discussed in the last lecture, quality depends upon budget, scope, and time. So time and budget, when they fluctuate, they result in increase or decrease of the scope that eventually affect the quality. So quality of software is sometimes less than adequate. As a result, there are softwares that were deployed but they were unreliable, and I will share some case studies with you. They were unsafe to use, they were inflexible. If there was change was not able to be implemented. They were even abandoned in certain cases. Software has been developed, but after using it, they said, we are better off without using this software. And there are security concerns as well, as we discussed about the CrowdStrike in the last lecture as well. So Arena 501, this was NASA space shuttle. Okay, they did a lot of planning in gathering the requirements. After gathering requirements, they did analysis, design, build everything, and when they launched this rocket, the launcher exploded after 37 seconds after the flight. And the reason was failure in software. Now, in case of this rocket, there were engineering teams are involved. There were many other teams from different disciplines were involved. It was a team collaborative activity. But a couple of issues in inertia reference system that resulted in an error and it got exploded. Similarly, this was another information system, London ambulance system, and it said that the people would not have died if they would not have used this software, because when they used the software failed and they were not able to provide service to the people, and people died because of software failure. This is another system, T-Rex. It basically, the issue was it gave laser overdose as a treatment to the patients, and also resulted in certain deaths. So see, in healthcare, the software is very critical. And the root cause was lack of quality assurance. As I mentioned, in ethical software engineering, if you don't know about that domain and you don't have training, ethically you have to come up and tell your organization, no, we can't do it because there's life and death situations involved. I don't have expertise. But people develop this software, and in this case, the root cause was quality assurance was lacking. Now, quality assurance is a process where during software development activities, you keep an eye. Are we developing the product in the right fashion? Standards are being followed and so on. So monitoring is involved. So that was lacking, and the software was over complex. Okay, so if you can build a thing in a simpler fashion, it's better to build in a simple fashion, because when things are simple, you can easily modify them. But if they are over complex, then it's difficult to modify them. There was inadequate testing and there was not much documentation. That even they identified this issue, still they were not able to correct that issue. Okay. Similarly, this was another Taurus. There was another automated transaction system which was deployed in London Stock Exchange. So it was an automated system for doing debit and credit sort of activities, and it resulted in loss of to the customer around 450 million. So instead of helping the customer to increase their revenue, it resulted in loss for the customer because the software did not function as expected. And again, as a result, they abandoned that software. They said, we are better off without using software. In TikTok, it has been recently reported that there is a bug in the code that if some developer knows about that code, he can exploit that bug and can basically reset the number of followers a person is being followed by. Again, this is a security issue, and again, it's a software bug that can lead to certain functionality, inappropriate functionalities. In aerospace industry, this is again recently published document where they basically identified that different incidents happen in aerospace industry. Let's categorize them and see their causes. And again, it is reported that 62% of those cases, the accident, software was responsible. There was certain issues in software design because the software engineer, they were not able to do the analysis good. They didn't understand the problem well. As an outcome, they were not able to design the solution well, and eventually it led to certain incidents. Okay, so 62% is a big number. So software has a pivotal role in many daily activities that we perform. And these are the few examples. Some of them are quite old, and the reason is because most of them were following waterfall model. Okay, and it was very difficult for them to anticipate the change in the environment. So if you look at the literature, you will find many other case studies. Okay, we will see that software failed to provide the required functionality, and authors link it back to issues with the analysis, design, implementation, quality assurance, and so on. Okay, so these are the challenges that we are facing as software engineer. But why we are facing this to a great extent? The reason is softwares are complex. We cannot visualize the software. If you have 3D model of a house, you can visualize it. Software, it's very difficult to visualize. It's very difficult to comprehend. So that is one of the biggest challenge that we face. Because they are complex, when we go for maintenance of the software, but somehow we have delivered the software and we saw that software is malfunctioning. It's not giving the proper dose. We are not able to update it in an efficient manner because maintenance is difficult. The way they have been developed, it's very hard to apply the update. Okay? So software are complex, and software maintenance is a big challenge for software engineers. So how basically software engineers basically address this problem? If I ask you, I give you a problem which is complex, and you're working in a group, how you will start working with that problem? You will try to understand it, and you will basically divide it into modules, into groups. Okay, this is how basically human being works. If something is complex, you cannot understand the complexity in one go. So we divide that problem into small problems. So this was a big problem, whatever it is. So, and we cannot solve it in a one go. So what do? We basically divide it into small little problems, and for each small problem we design a solution. Problem, we have a solution, and we put together those solutions to give the overall solution for that problem. Okay, this is what we do, divide and conquer approach. And all of these, which small subset, we call them module. Now it depends upon granularity. If the system is quite complex, for example, this is a very complex system. This is enterprise resource planning system. Then each of these could be a subsystem. This will be supply chain management system. This will be human resource system. This could be accounting management system, product management system, supplier management system. If it is a system, then these could be modules. For example, if it is a university management system, then this would be teachers module, student modules, timetable module, building module, lecture module, and so on. Okay, so depending upon granularity, this is how we basically divide the problem. But once we solve them, then we need to identify that individually they cannot give the emergent behavior, the overall solution. So it means they need to communicate with each other. Okay, so this is the process we are talking about. These are the components in a system, or modules. Okay, when I say module or component, I mean same thing. Okay, so these are different modules in a system, and these are the communications links among these systems. Because a process of delivering the lecture need lecturer, student, and the building to be scheduled for a certain period of time. Okay, so this is how communication works. And in your first workshop, you will basically look at the system, and then you have to identify these components and the processes that are being implemented in these components that may be communicating with other modules if required. Okay. So this overall is called as architecture of a system, so architecture of a software. And regarding architecture, we will discuss in more detail about in week 6. So this entire is basically called as software architecture. Software architecture is a skeleton of the system. Human bodies has a skeleton, and that's the core of our body. If our skeleton deshape, our functionality will be affected. Similarly, software has an architecture, and we call it software architecture, which is skeleton of the system. And that's of great importance, and we will discuss about software architecture in more detail in week 6 and 7. Okay? But right now we have these modules, and these modules need to talk to each other. And in this context, we use two terminologies, cohesion and coupling. Okay? Before coming to the module, let's look at this example. What is cohesion and what is coupling? Cohesion is if we have a component, a module, or some thing, it does only one task, one specific task. For example, this knife is very cohesive. It has high cohesion because it is only doing one task. But this knife has low cohesion because this is knife, but this knife is doing many tasks. Okay, so this is high cohesion and low cohesion. Now coming up to the modules. If a module is doing specifically one task, we call it high cohesive module. For example, this is a teacher module. Now teachers need to prepare the lectures, teacher need to supervise students, teacher needs to maintain the canvas site. All these things that are related to the teacher should be done by this teacher module. It has nothing to do with student module. Similarly, we have student module, all the functionalities that we want that student will perform, they should be defined in student module. Okay. So why we are doing this? Because softwares are complex and maintaining software is a challenge. And when I say maintaining, it means we may need to update the software. If we know that the modules are cohesive and the change which we need to apply is regarding the teacher functionality, then we can quickly come to this module. Okay. So we need to be highly cohesive, but it cannot be absolute cohesion because modules eventually depend upon other module to achieve certain functionality. But our objective is the module should be highly cohesive as much as we want. Okay? So this is cohesion. What is coupling? Coupling is how much they depend on each other. Okay? If you look at this figure, this is loose coupling because rowing a boat, this person does not depend on other. Even if this person, the second lady is not there, still he can row the boat. But in this case, they are highly dependent. They need to coordinate their activities to get a certain acceleration. Okay? So coupling is how much they depend on each other. So these connections shows the coupling. Now in system, we have components, and component will have certain cohesion and they will have certain coupling. You cannot remove the coupling because coupling is required. We need to interact so that we can achieve the task. This lecture delivery, for example, it needs some functionality of student. For example, this blue is lecture delivery module. It needs some teacher information, it needs student information, it needs building information. So this module will pull this information from these modules, communicate with them, who is delivering lecture at this time to whom and in which room, then this will work. So we cannot have absolute cohesion, we cannot remove coupling. So there will be some degree of cohesion among within the module, and there will be some degree of coupling among the module. But these cohesion and coupling are characteristics of software design. Like you student, if you are punctual, it's your characteristic. If you get high grades, it's your characteristics. Similarly, software architecture, which is this skeleton, the modules and connection, if they have these characteristics like cohesion and coupling to on good side, then we say they are good software. Okay, so these are the two characteristics that determine whether software is good or bad. Okay, And I will explain it further on the upcoming slides. So what do we know from this slide? That we have a system, problem is complex, we break down into small modules. Each module should be cohesive enough so that if we have to change something regarding that functionality, we don't need to look around and see which module has implemented it. There will be higher probability we can identify that module quickly and we can apply the change. Okay? And if cohesion is high, coupling is low, we say software is good. Any confusion, question? Good? So now we'll drill them in more detail. So coupling is the measure of number and types of interconnection. So we discussed that coupling is how much they need to communicate with each other. So that is the number is being used over here. And the type basically, now one module, for example calculator, may need sub-module, for example sum, to compute two numbers. Similarly, the calculator may call another module which is multiplication to do the multiplication. Okay, so such sort of dependence is called functional dependence. Okay, other could be procedural dependence. For example, we have three modules. We give all the information to one module to transform that information from voice signal to textual information. Once that module finishes the functionality, the output will be given to second module that basically apply certain AI algorithm to understand it. The output of second module will be given to third module to basically create visualization. So such dependence or connection is called procedural dependence. Okay, you will see something. I haven't mentioned anything on slide, but I am explaining it. So objective is some of you who may have who basically doing bachelor in software engineering, it is more beneficial to them. But if you are in masters and the information is not there and you didn't get it, don't worry. It will not affect your upcoming learning. Okay. So we have coupling. We have different types of coupling, and if coupling is low, the dependencies is minimal. That component can work on its own, and there is less dependence. Now, because there is coupling involved, it means they need to talk to each other. Component A needs to talk to component B to get some information. Okay, so how that communication will be done? So instead of having many ways of communication, we should have well-defined way of communication. For those who have done programming, this is called as method call. When we call a method, we basically pass certain arguments, A and B. If you give A and B, then you get the response. So that is called as interface. So when modules need to communicate with each other, there should be well-defined protocol how we should communicate. Okay, if you are two students working in a group and you define among yourself, okay, if I finish my task, I will just say done, and when you hear done, you basically submit your work. So that done is a protocol between two persons that okay when they will finish the work. So this in technical language you call it interface. Okay, so modules have interfaces, and those interfaces define how you can call those modules. And these interfaces encapsulate the knowledge which other people who are calling don't need to be worry about. Okay, so for example, there is a calculator module, and calculator modules, and this is some sub-module to basically some two numbers. The calculator modules send information, two numbers to this module to calculate them. Now how the sum is being calculated is hidden over here, because this is within this module and the interface is exposed to the other module. Other modules only know that this is an interface. Okay, so when information come over here, this module will basically calculate the sum and return it to the calculator module. So now this sum module we can update anytime without affecting other module. Calculator module don't need to worry about what is happening inside this module. We can apply simple sum method, we can apply complex sum method, maybe certain applying certain integral, whatever. Okay, but the calculator module doesn't need to worry about. So this is called as encapsulation. So now we can make changes within this module without affecting rest of the components. The rest of the components don't need to worry about what changes we are making over here. The only thing they are worried about, the interface. That when I need that module, I need to send two numbers, and that module will respond with the sum of two numbers. Okay, so this is called encapsulation, that the functionality is hidden within that module, interface is well defined, other modules don't need to worry about what changes are being implemented over there. Okay, so that's for coupling. And cohesion is how many functionalities a module is performing, and if there's only one functionality that module is doing, we call it very cohesive. And again, because module have well-defined interface, whatever changes we will do in that module, as long as we don't change the interface, other modules will not be affected. Okay. If you recall, in the last lecture, I mentioned, we discussed a graph where we have time and we have errors. Time was on x-axis and error was on a y-axis. And we said that when we release the software, over a period of time, the number of errors reduces because we have tested everything. Eventually, the number of errors are reduced. But as soon as we make a change, number of errors increase. And as we make a change, number of errors increase. And then we start addressing those errors. If interfaces are well defined and we make a change, then this curve will not be too much steep because it does not affect the other modules. No errors will come in other modules because the change is localized. Make sense? So here we established that if this is Constantine's law, a structure is stable. When structure is used, we are talking about software architecture. Okay, the skeleton of the system, the structure of the system is stable, is strong. Okay, if it is stable, let's understand what is unstable. Unstable is the one when you make a change, then it has a ripple effect and it affects other modules. If it does not affect other modules, then your change is localized and your system is stable. Okay, so a structure is stable if cohesion is strong, cohesion is high, and coupling is low. So when you design your system, you did the analysis, and then you started designing of your system, and you identified that, okay, in my system these are the 5 modules, and the modules are highly cohesive as much as you can do. You cannot have absolute cohesion because it is not going to work. And coupling is low. Modules need to talk to each other, but it's to a minimum level. Okay, if you have achieved these 2 characteristics, then your structure, software architecture, skeleton of your software is more stable. And if thing is stable, you bring in change, it can retain that change. Okay, so this comes as an outcome of modular software development. Okay, so as I mentioned earlier, if you have a big problem, instead of addressing that problem as a whole, we divide it into modules. Problems, each small problem we consider as a one module. Okay, and each module provides a solution, and we put them together to give the overall solution as a software solution. Okay, so modularity defines with interfaces allow us for more reusable software. Okay, we want software to be reused. We should not be building each and every functionality from scratch. Okay, university, for example, started with a student management system, and then they started developing another management system like library management system. Now, library does need some functionality from students. So it might be possible that student management system, which has 10 modules, one module can be reused in library management system that can pull all the information of the student. Okay, so we want software to be reused. And when we are able to reuse them, it increases productivity of the developer. Now, the developer don't need to code everything from scratch. He can look at existing information system and can reuse those modules. Or if the application is, for example, e-commerce website, now there's no need of development from scratch. Existing modules are available. If you recall, we discussed the third option of software development: configuration, integration, and configuration. You can reuse existing components, configure them, you have entire functionality. Okay, so that is only possible through modular software development. It also leads to fewer bugs. How come modular software development leads to fewer bugs? What do you think? So we are talking about modules. We say that modules can be reused, which is a good thing, and also leads to fewer bugs in the modules. Why? Yep.
Because since you're not remaking the same modules, you're less likely to code an incorrect line.
Yes, and so you're not making any changes, you're not creating any new, and you are reusing it, and that has been tested already. And when it's reused, it has been tested again, so you are testing that module again and again. Because when you plug it in current software, it's working fine, it means that module has been tested again. So because of reusability, it is going through continuous testing, so it leads to fewer bugs. And the software will be more maintainable. So in early 90s, the issue was maintenance of the software. Okay, and modular software development provided a solution to easily maintain the software. Okay. And this picture basically depicts the concepts we just covered, that within a module, for example, this concept is a subsystem. Now, all the components, module within this subsystem, for this subsystem, we consider as a high cohesion of the subsystem. Okay, and when we go to this module, we can say this module is highly cohesive within this subsystem. And these are the links of shows coupling within that subsystem, and these links shows coupling between subsystems and so on. Okay. So modular software development is good. It addressed many concerns that software engineers were facing. But the challenge is how to define good modules, because this is subjective term. This is not mathematical formula. If I give each of you very simple problem, each one of you may define modules differently with some variation, and all of them may provide the required functionality. But some of them were difficult to maintain. Some were easy to maintain. All of them are giving a functionality, but the way you have designed it, there will be changes. So how good modules are with required interfaces, okay, well-defined interfaces, that we don't need to change the interface, because if you change the interface, there will be a ripple effect that you need to cater for. And second is specify software architecture to support the component. Now this software architecture is very important. As I mentioned, just keep an example of architecture of building, human skeleton. It's the core. It's very hard to change. Okay, and if you have to change the software architecture, then it's very expensive. Okay, and I will establish these points when we go to topic of software architecture. So any question up till now? Cohesion, coupling, these are two characteristics of a system. Okay, and the system that we design would have components that should be highly cohesive. They should communicate with other components, that is coupling. If cohesion is high, coupling is low, our system is more stable. We are able to maintain that system. We are able to make changes to that system quite easily. Okay.
Excuse me.
Yep.
Is cohesion and coupling have a specific number to mention it?
Now, if I mentioned that these are two characteristics. When you get high distinction, we know you got 80 plus or 84 plus. Okay, we have something to measure. If we cannot measure something, then hard to gauge. Okay, there are ways we can measure, and I did not include it in this lecture, but there are ways. Like I mentioned, functional cohesion, procedural cohesion. We can rank them. We can say that functional cohesion is good, but we should avoid procedural cohesion. So there has been research where there is ranking for cohesion and coupling. For those who have done programming, coupling is basically when you implement certain interfaces you inherit from other classes. Okay, so those are coupling. Method coupling would be when you're calling the method. So there are ways to measure them. Okay, but I'm not discussing them over here. So cohesion and coupling, they can be measured, and you can say, okay, this software is good, but how much good? This software is bad, but how much bad? So there are ways. If you drop me an email, I can forward you that information. Okay. Anyone else? Yep.
What do I do if I want to change a module?
You want to change a module? Yes. If you want to change the module, you have to see how would other modules will affect it. Because entire module is being removed or added, then all those links, they need to be addressed. Other modules depend on that module. So you have to provide solution how those modules will get the functionality. So when you're removing module, you have to think of the changes, because all other modules that would be communicating with that module, they need to be updated as well. Okay. Okay, so that was regarding software problem and what software engineering do. Now we go to agile software development, and in the last lecture we discussed about plan-driven software development in detail. Okay, where you have to pre-plan, get all the requirements, then do all the analysis, then do all the design, and you cannot go back and so on. And we said that this plan-driven development is not possible when environment is changing rapidly. Okay, and then we said incremental development is a way forward, and incremental development is basically agile software engineering. But we established that it's not that there's something wrong with waterfall model. Waterfall model is still a good model if you apply in a context where it is required. And those contexts we discussed, and one of example is safety critical system. If we have to implement safety critical system in certain infrastructure, then you have to get all the requirements first. It's not like that you get some requirements and go for analysis and design and come back again for requirements. You cannot do it. So waterfall model, plan-driven model still works, but it depends upon the context. And one of such contexts is safety critical system. But it's not going to develop for the application that we see around, for social media app, for e-commerce websites, for other applications where environment has influence, a lot of influence. And we established that for that we need agile methods, because in agile method we don't gather all the requirements in one go. Rather we get some requirements, quickly do some design, do development, and release the software so that people start using it, and then we send the updates, second release, third release, fourth release, fifth release, and so on. And what are the common characteristics of agile software engineering? Specification, design, implementation are interleaved. There are no fixed boundaries. And instead of having the software giving traditionally in waterfall model, you have to give the entire software in one go to the client. This is your software, now start using it. In case of this agile software engineering, we give bits and pieces. Okay, we keep the customer engaged. Okay, take this little system, start using it. We will send you the second release with more functionality and so on. An extensive tool support is required because we are doing in increments. We need tool support. How much we have done, where we are, what functionality we have to do for next iteration and so on. And in today's lecture, when we discuss agile methodologies, we discuss in more detail. So this agile manifesto is the thing which basically people came up with to address the issues they were facing with waterfall model. And what does it say at the manifesto? It was published around in 2001. We are uncovering better ways of developing software by doing. Don't need to do too much planning. Don't worry about too much planning. Start doing it. By doing it and helping others do it. So there's team involved. Start doing it and helping others to doing it. Through this we have come to the value. Eventually software is the thing which value for the customer. So we don't need to plan too much. Start doing it. So this is agile methodology. And how they achieve it? They says individual, and they give preference to individuals, the people who have skill set, who know the certain programming design very well, and interaction among them in a team over process and tools. In waterfall model, process is important. You cannot go back. There are tools that you need to use. But over here we are saying that don't worry about tools and processes. We don't need to be strict about them. What we need to worry about? Individuals. We have to value the individuals, the skill they have, and how they interact in a team. Working software. Don't need to do too much documentation. Maybe you are in planning, you have spent 6 months just for the documentation. Okay, so we value the working software. We should come up with working software as soon as possible. We need to collaborate with the customer. It's not like that customer is involved in the requirements gathering, then it is not involved in analysis, design, implementation. We should not do it. And we should be ready for the change. Okay, because we are releasing the software in increments, we should be ready that the thing which you are thinking right now may change, and so on. So this is Agile Manifesto. You can go through just the information in detail. So what is basically the difference as depicted on this slide is, in case of plan-based, we do the requirements engineering, we do document the requirements, and then we go for design. And if something wrong happens over there after implementation, when we did testing or we did deploy on client machine, then we'll come back and fix them. When in case of Agile, we are flexible. We can move from design back to requirements gathering, from analysis back to gathering, and so on. So we release the software in increments, and stakeholders involved in version specification and evaluation. So now customer involvement is very much highlighted in this Agile Manifesto. So frequent delivery of the softwares, there is a tool support available that helps these teams to communicate and also to follow up their work, and the documentation is to a minimum level so that we can make the team working. Okay, it's not pre-planning involved, a lot of documentation for clients to sign off. So these Agile methods basically, we can look at a fair bit of detail. Customer involvement. So customer is involved regularly in requirement gathering as well as prioritizing the requirements for that increment. Because we are releasing the software increments, so the first increment, what should we release? Customer is involved. He can tell you, okay, these are the functionalities which we need immediately. And delivery is incremental fashion. Again, customer specify which components or functionalities he needs early. And development team with the people they involved in, they define their way how they will proceed. They can define the process. We don't define the process, how they will communicate with each other, how they will work each other. Okay, so the team itself define their process to basically do analysis, design, and so on. And they embrace change, and the things are built in simple fashion. Okay, simplicity is the key. It is quite possible that you build a software that's very complex but giving the same functionality, because you apply an algorithm that's quite complex. But if you can apply 3 simple algorithms to achieve the same functionality, that's a better approach. Okay. So Agile methodology, basically the philosophy is, we cannot predict the future. Even if we can predict the future, we cannot anticipate that future which we have predicted will remain, because it will change. So Agile methodologies appreciate the change. They accommodate the change. And these 4 methodologies, we will see that how they accommodate the change and how basically they release the software in small increments. Any questions so far? No? Okay. Okay, then we can take break. And then we will start again at 2 o'clock. Okay, you have 15 minutes break. I can pause the recording. Okay, recording has started. Okay, before I go to these Agile methodologies, one of the fellow students asked me a question about what are safety critical systems for whom we prefer to use plan waterfall methodology. One such example is, for example, in ICU, if you are building a software that may be pulling information from various sensors, heartbeat, temperature, pulse, and so on. So that software is of great safety concern for in that environment. So that is an example of safety critical system. Similarly, you have these infrastructures like electricity, smart grid. Those infrastructures are very critical. Downtime of electricity can result in loss of businesses as well as loss of life in case of hospitals. So those are safety critical systems where if something happens, it could lead to a very harmful effect, could be a life and death situation. So all those systems for that environment, they are safety critical systems. And I share some of the example, they were safety critical systems. So agile methodologies are iterative and incremental. We understood the concept of incremental last time. Let's drill down a bit further. So we know that incremental is basically we are releasing the software and the release is functional. Client can run it, client can use it. For example, we have three features in e-commerce website. A is about products functionality related feature, B is about shopping cart functionality, and C is about payment functionality. So this A is fully developed product functionality. It will have products, you can add names, you can add feature, colors, photographs, price, each and everything. This is a complete module functionality of products. And then you build the second complete module and then third complete module. So each one is one increment, okay, workable solution. Now what is iterative? Iterative development is again quite common being used. In iterative development, instead of having complete functional final module, we basically build the module in small iterations. For example, this is first iteration in which regarding products functionality, we are just providing functionality that you can add product name and price. That's it. No photos, nothing. That's enough. Regarding B, shopping cart, this shopping cart can, you can add products of only one type. That's it. If you are buying eggs, then only eggs can be added into the basket and you can check out. Okay. Regarding C, we may implement that, okay, you need to submit your payment information. There's no online payment, but you can submit payment information so that a person, clerk on our side can make the deduction. So this is first iteration. In second iteration, we improve all those modules. Now regarding product functionality, we added previously name and price. Now we are providing more features, images, blah blah and so on. Similarly for second and similarly for third features. So this is the second iteration. So we are building the entire solution but in increments. So I'm using the word now increment. So increment is anything which is a workable solution we give to the client. So in this case, we are not confined to one feature, rather we are looking at all the functionalities, but we are starting from very raw functionality and we keep on adding to reach the final product. But this you can think of is first increment because it's a workable solution and so on. So when we say iterative and incremental, agile methodologies are iterative and incremental, what does it mean? It means that we are doing iterations, but also in those iterations we are doing increments as well. Okay. For example, A would have implemented completely, but B and C some functionality, and so on. In each iteration, we basically improve and build on what is the previous. So this is how iteration, the incremental development, and iterative development differ from each other, and when we combine them, we get iterative and incremental development. Okay? Confused? No? If you just, the figures I have created, just focus on them, then you will be able to understand it. So agile methodologies are iterative and incremental. That understanding is good enough for us. Now let's start with the first methodology. Extreme programming. As the name suggests, they are the people who say, let's start doing it. Don't worry about planning. We do, and we do continual planning. This is the philosophy in Agile, as I mentioned before, that we cannot predict the future. And this started in early 90s when World Wide Web was introduced. Okay, so the environment was changing rapidly. Internet was there, World Wide Web was there, so environment was changing rapidly. So this extreme programming was introduced. And in this methodology, following key practices were introduced. Okay, I will go through them one by one on next slide. So what is this? This is extreme approach. What we do, we basically get some requirements from the user, and those requirements we call them user stories, like storytelling. Every story has certain narrative and it has some starting, some ending, and it conveys the meaning. Okay, so similarly for requirements, we basically say, tell us your story. The customer then tells his story, that how does he work. Once we have stories, we basically understand story and identify the tasks, and then we start planning for development of those tasks, and when they will be released, when increment will be released, because increment is workable, functional piece of code. So when the software is being developed, released, then it will be evaluated, and again, customer is involved right from the beginning till the end, and then go to another story and so on, collect for the story. So this is how this works. So new versions may be built several times per day. Okay, so the development cycle is very short in agile methodology. Okay, normally it goes from 1 week to 2 weeks or 3 weeks, and you will have something working. But in case of extreme programming, you might have this a new version maybe many times built in a day, because you are rapidly doing the development. But after 2 weeks, you have to release the increment to the customer. So the time period after which increment should be released is 2 weeks, and you are working extremely focusing on programming, because a lot of is being programmed with very few planning, very few analyses are designed just on the move, on the go. So it's very important to test what you have developed. Okay, so testing is again very integral part of extreme programming. Okay, and let's look at each of those practices one by one. So what is a user story, which is a requirement, which is a starting point? A user story is generally one sentence description of a work-related task done by the user achieving some goal or result. Okay, so this is what that person is doing. And the template is, he can mention that as in this role, I want to achieve this, and that goal could be quite broad because his task is very complex, or it could be very short, so that I can achieve these benefits. Okay, this example will make it more clear. For example, this is a user story for a shipping clerk, and he says, as a shipping clerk, I want to be able to ship an order. So ship an order is a task that he wants to achieve, and it will have, it's a process that would have certain inputs and certain outputs or output. So as accurately as possible, as soon as the order details are available, okay, so that the order is shipped quickly and accurately. So these are the qualifiers: quickly, accurately, are the benefits. This is the task in this role. So this is a user story. So the extreme programming people, they basically start with this user story. And with this user story, they also develop acceptance criteria. This is a testing criteria, that this story once get implemented and you release increment, that increment would not be accepted by the client unless these conditions are met. So this is a testing criteria. And what is this? There should be a pop-up available for order details. There should be a portable display and scan device to cut time in half, sort the items by bin. So all these functionalities should be in that increment. If they are, then that increment would be accepted. So this is called acceptance criteria. So that story was very simple. Now this story is a bit long. Again, as a whatever person, he wants to do all these tasks so that he can better manage the whatever area is working on. So what do we do? From this user story, we identify the tasks. For example, in this case, change of dose, formulary selection, dose checking. So these 3 tasks are involved in this user story. Okay. So these were identified, and then these would be used for scheduling of the task, how they will be implemented, and also for cost estimation. So this is extreme programming scenario. We didn't do much planning. We started with the user story, we identified the task, and we distributed the task to the teams. And they start coding, and in 2 weeks we have to give a workable solution to the client. So that was user stories. Now, in case of this extreme programming, we are rapidly developing the software. It's just like you, civil engineer, without any planning, start building the house. He would be able to make the wall maybe accurately, 2 houses maybe accurately. On first floor, that will be fine, but as soon as keep doing like this, he will run a situation where the building maybe reach a situation where he cannot add anything to the building, and may result to unstable structure. Because there is no planning involved, and rapidly He is constructing the building. Similarly, in this scenario, we are constructing the software rapidly. It might be possible that the software, the modules, the structure is not stable. Okay. So how they address this scenario? So they do refactoring. What is refactoring? After we done with some development, now sit back and look at that overall solution. Is it good? Can we modify the structure? Because the way we have structured modules, cohesion is low and coupling is very high. Can we redo refactoring? Can we adjust them? Can we change them? Can we merge these two modules? Can we split this module into two modules? So this is called refactoring, changing the structure of your software. So this is what they do. Because if they don't do this, it may result in a situation where the skeleton, the software architecture, does not allow any change, because otherwise the building may fall, software may crash, and so on. So the refactoring they do regularly. Second is test for development. The acceptance criteria they have defined, it will be translated to generate the test cases. Now in next software engineering course, which is software quality assurance and testing, you will discuss about these things in more detail. So what functionalities should be in a criteria? That has been defined before the implementation. Because when stories are defined, acceptance criteria is defined. That acceptance criteria is a testing criteria. And then using that acceptance criteria, test cases would be generated. Okay, test case is basically someone will test the software, it is working accordingly or not. He will give some inputs and he knows that output should be this. So he will check the output of the software. If output is as expected, test case is passed. If not, test case is failed. So in these cases, we have to define test cases first. And the third is pair programming. Now programming is done in pairs. So two developers, they would be given one task. One will start coding, other may be viewing it, or maybe he's not around. But next day, the other will start coding. He will look at the code of the previous one. So this is pair programming, the way you work in assignments. You have an assignment, both of you basically work together. So this is called pair programming. So pair programming idea was introduced in extreme programming. So this leads to common ownership of the code. Both the people basically take ownership, and also spreads the knowledge. If one of you is senior, the junior can learn from the senior how he has coded. So it's again learning is involved. Besides learning, the senior person is reviewing your code, the one you have done. Because in pair programming we have two programmers. So there is an informal review is also going on. So the senior person is looking at your code, trying to understand it so that he can extend the functionality. Okay. And encourage refactoring, because eventually when two people are working, they may code in different styles, fashions, so refactoring is important as well. So this is extreme programming. Agile approach in which not much planning is involved, and we say let's start developing it. Okay. So extreme programming was introduced in 1990, I believe, and this rational unified process was introduced by IBM around 2003. Again, this is agile methodology. And how does it work is being depicted in this slide over here. So this RUP, rational unified process, works on iterations. Okay. For example, if you look over here, remember this 6 core processes? The first core process identify the problem, second is plan, then analysis, then design, then build, and then deploy. So these are the 6 core processes. In extreme programming, the planning and these phases are almost not there, but they do something. Okay, there is very minimum planning is involved, not aggressive. Okay, so these core processes would be there, no matter which agile method we are using. So now this is first iteration in which we try to get as much information as possible. Then we go and do planning, then do some analysis, then design, and then build something. But that something is not useful to the client. Client cannot use it. So there is no increment over here. Okay. So this is first iteration. In second iteration, we take into consideration some additional requirements, but now there is more analysis, design, and there is more workable solution now, but still it's not being deployed. So there is no increment. In third iteration, very minute further requirements are considered, but analysis, design, now they they have been, the quantity has increased, and now we have built a system which is of reasonable size, and now that we can deploy it on client machine and client can start using it. Okay, so this we can say first increment if we want to relate increment over here. Okay, so after 3 iterations we got first increment. So this is work in increments, and as you can see the hump of in each this area, as we move diagonally we are going away from the requirements and we are going more towards complete software solution. Okay, so this is iterative software development. Okay, and we call it RUP. Scrum is another very famous and widely used nowadays agile methodology. Okay, and it is being used widely across the world for software development. Not safety critical system, but for the business related, social media related, all those applications where requirements changes rapidly. Okay. So this Scrum name basically they borrowed from in rugby a team come together and make a strategy to win the match. So the Scrum word is used over there for a big team. So they borrowed it from there. So what it does basically, it is a framework that helps teams to manage work, and what we are talking about over here, software development. Okay, and solve problems in short cycle collaboratively. Like same philosophy like extreme programming, that we have to develop the software in increments within short cycle, same philosophy is over here. But how it's different we will see. It implements the principle of agile as concrete set of artifacts, practices and rules. So the main ingredients of Scrum is that there are certain artifacts involved. There are certain documentation elements are involved, which we call them artifacts. There are certain practices involved. The people basically do certain activities. We call them practices, and people have taken certain role to work in this environment. So let's look at this Scrum related methodology. So first of all, we have product owner. This is the person who basically interact with the customer, identify the requirements, and give those requirements to the team for design, for analysis, design, and development. So this is the one who will say what will go in the product and interact with the client. So this is the product owner. So product owner will basically create a list of requirements which you call product backlog. Okay, we will say why it's called backlog, but this is product log, and after each cycle we have to look at what has been met or not. That's why it says it is being said backlog. So but this is from where we get the requirements, and they will, requirements will push down to development team. Now development team, we have developers and we have Scrum Master. Scrum Master is the one that is the manager. He is responsible for entire process, all the teams and so on. Okay. So in order to start development, the Scrum Master basically start a meeting which is called sprint planning. Now the software that will be built in this iteration is called sprint. Okay. So that's why it's called sprint planning. The software that we have to look at some requirements, and then we have to develop something, and that is called a sprint. So that planning is done over here, and this is sprint backlog. So they did some planning and they identified user stories or functional requirements, okay, to develop, and they will be recorded on a board, for example, okay, which we can call Scrum board. Okay, this is what we need to do, and so on. And as the team start developing those, the Scrum board got updated. Okay, these were the started, these one have been done, these are in testing phase and so on. So this information is maintained on the Scrum board. So when this sprint planning team push tasks for the developer, the team will start developing it. Okay, maybe it's a 2-week sprint or maybe 1-week sprint. After the time completes, they have to basically release the software as a part of the increment. So within a week, they daily do Scrum meetings as well, which is called as daily Scrum. So they have been given certain requirements, they started working. So this first day, they will do a meeting. In that meeting, they will say, okay, what do we need to do? And in this team, there are analysts there are designers there, and also the coder. So this is a team that contains all the roles, and they basically do this meeting, and they do it daily. And in that meeting, they decide, okay, who will do what, how long it will take, are there any dependencies, what are hindrances, all these things are discussed in this daily meeting, and then they start development. After a week, they will finish a sprint, they will update the backlog, sprint backlog, will tick the task, and if that sprint is good enough to be released as an increment, it will be released. Okay, and once that sprint is complete, validation testing of sprint is also part of it, which is basically reviewing, which is demonstration to the client called sprint review. Okay, you can demonstrate to the client how the sprint is working, the functionality. Besides sprint meeting, there is sprint retrospective, in which again the team sit together and see what went well, what went wrong. Okay, because there is not much planning involved over here. There is some planning involved over here, but this planning is not that long-term planning. So this planning is just identify the requirements, again in consideration with the client, that we need to build quickly. So in this retrospective, they look at what went well, what went wrong, so that next time it could be improved. So there is continuous improvement process involved over here, that continuously they are doing these meetings and improving their processes. So if everything is good, it will deliver to the customer, and product backlog will be updated. Now, while doing this sprint review, it might possible that new requirements may come in. The client say, okay, you have done this, but I also want this, or maybe change this. So those new requirements or changes will come back to the product log as well. So that's why it's called product backlog. So anything is new or changes, they will come over here, and then they will be pushed back to the development team. Scrum Master will do the meeting, they will do sprint planning, and then they start developing the sprint, and so on. So this is how Scrum works. Okay, it's very agile. You see, mostly it relies on the skill set of the people who are involved in the team. Okay, the developer, designer, implementation, tester, all of them are part of the team, and they are the one who do these Scrum daily meetings, address the issues, and move forward. So communication is one of the building block of these agile methodologies, especially Scrum. There is some planning involved, but that is not as we do in a waterfall model. So the artifacts over here is a product backlog, sprint backlog. Okay, the practices over here are like daily Scrum, sprint review, retrospective. So these are cultural things. They basically develop this culture in their organization that we have to review our work. Okay, and so on. And the roles over here, we have product owner is well-defined role. We have Scrum Master well-defined role. So this is a Scrum methodology where we are rapidly developing the software. It's different from extreme programming. Extreme programming, there's pair programming, there's refactoring involved. But over here, we have these meetings and these Scrum meetings that can help you to better design the software. You may not require refactoring. So to tackle those things, these meetings are important. These two meetings, and so on. So this is Scrum, and very famous methodology. And again, this is not prescriptive. This is at some certain level of abstraction. Each organization would have their own steps they would be performing within sprint planning. Within the development, they might have used certain specific tools to track their progress and so on. So this is not very prescriptive. Within organization, once it implemented, there will be more details. Okay. Any question? Okay. So this was Scrum. There are a lot of benefits, especially if we go to distributed Scrum, then definitely we need to ensure that the product owner is in the one who is interacting with the client should be able to communicate with the Scrum Master and the team frequently. Similarly, there should be video conferencing to ensure that the communication related stuff is going accordingly, because communication is one of the core of this Scrum. And unstable requirement don't hold up the progress. So if the requirement is unstable, you find out that this requirement is changing rapidly, we need to stop looking at it for a while, then it's quite easily, because you are developing in small sprints. You can quickly change your direction. Okay, so this is more agility. As soon as, instead of forcing the future after 3 months ahead, you are forcing the future which is 2 weeks ahead. So if after 2 weeks something happens, you can quickly change yourself. So this is the agility that this methodology brings in. And you get feedback from the customer, and again, it develops a positive culture within the organization. Second is Kanban. Again, this is agile methodology. It almost works similar the way Scrum works. But in this case, Kanban, there's no Scrum planning, sprint planning. There's no sprint in case of Kanban. So over here, instead of sprint, they consider continuous development. They have a product backlog and continuously get requirements from backlog and implement and keep implementing them. So there's no sprint concept over here, there's no sprint planning and so on. But what do they have over here? The issue with Scrum is that the sprint planning result into pushing certain information to the developers that these 5 stories should be implemented. And that team, because of time constraint, may not be able to deliver the quality. So there's a push involved in Scrum. If I go back over here. So this is a push that these developers have been given some stories. Although there is planning, but still, this is a push over here. In case of Kanban, this is not the case. Over here, each and every team and developer, they have a capacity, and the new task would be given to them only if they have completed their previous task. They cannot go do more than what they are expected to do. So this is the strength of Kanban. So in Kanban, it's more unstructured, and mostly senior people, if involved in a team, they basically go for Kanban. Otherwise, people go for Scrum, where if a person is new, then those planning meetings are important because it gives them a better understanding, especially to the new person, how to implement them. So the difference between Kanban and Scrum is more towards the push side. Kanban is towards pull side, where from product backlog, these developers would be given the task depending upon how much they have done so far. And this is continuous development. There is no sprint. So they're continuously developing depending upon the product log, and they're releasing the software. So these two methodologies, Scrum and Kanban, they have been used widely nowadays for developing the applications, especially for businesses, for non-safety critical systems. Any question? And again, there's a lot of literature available on the internet. You can look at further details, and if you want, I can provide you more resources. Okay, now we can just look at this case study, that if we are doing agile methodology, then how will you perform these activities? Not specific to Scrum or Kanban, but overall as an agile methodology. So this is a Ridge Line Mountain Outfitter. So this is a company who basically stitch clothing for skiing, mountain biking, and so on. They have established their websites, and they have certain e-business component. So this is a company that embarked on a business, and they do this clothing stuff, and they have developed certain processes in which they receive orders on the phone and mail on the mail, and they have certain e-commerce applications that basically provide functionality to their businesses. So in short, a company, some functions are online, some, for example, these mail order and phone order, they are accepting as well. Maybe they are not automated yet. So this is a company. Now, the problem is, in order to purchase cloth for these products which they are stitching, they need to go to trade shows. So their employees, they go to the trade shows where different companies comes with their product, and they display it over there, and the employee of this company goes to those trade shows and put orders for purchase of the cloth. So this is a scenario, and what they need is, they need an application. Once they are there, right now there is no system that they can place an order to those customers. Right now, when they come back from trade show, then they go to their office and fill in a form and say that this is a supplier, located somewhere over there, and we need to purchase this much stuff from their supplier. So right now this is doing. So what they need is, they need an information system. They need an application which they would have on the tablet, for example, of their employees. When they go to the trade show, they can quickly add the information and can place the order. So this is their requirement. Okay, you got the scenario? So in short, what they need is, they need basically a trade show project. Basically they need two systems. One is supply information system, and second is product information system. How they came to know about these systems? Customer came with the problem to us and had a discussion with, for example, product owner, and product owner, after understanding everything, told them, okay, you need two subsystems. One should be supply information system, and the second should be product information system. And the customer say, yes, that's excellent, let's start working on it. So initial activity, pre-project, which is, we can consider as a starting point, maybe day one. So what we will do, we will quickly build supply vision document. And what is this document? Basically, we do some preliminary investigation. We'll ask them some questions, or maybe look at their website, what these companies are all about, and what they want to achieve, because product owner has communicated with them. And we create system vision document. And what is this system vision document? It basically describes the problem. Okay, client told us, but now we have written description of the problem. Okay, traders show have become an important information source for new product and blah blah blah, and their employees need to need some information system so that they can place orders while they are attending the trade show. So this is the problem. What capabilities we want from the system, the functionalities from the system, we have to list them. Okay. We cannot list all of them, depending upon whatever information we have, because this is agile. Okay, whatever information we get, we will document them, and what benefits it will bring to them. Okay, because approval of this project needs this information so that the customer can discuss in their board meetings and can justify for this decision. So this is system vision document. Once everything is documented, system vision document is created, then it needs approval from the client. Okay, and it would be meetings would be done with the clients and the stakeholders. The requirements maybe they might say, we also need this functionality, so you update so vision requirement. Eventually, you reach to a consensus where the client is happy to sign the contract. Okay, so these are pre-project activities, and these are correspond to core process 1. Which is identify the problem or need. So after this, day 1 activity is basically we start with planning. Okay, these people will basically would be one team for analysis. These people will be another team for design. These people will be the third team for development, and so on. So we do these different activities in a day. So in that we identify, okay, these are the major components. For example, there are 2 subsystems, and we basically identify how we will start working on these things. For example, if you look at this work breakdown structure, so develop project plan, and then meet with purchasing agent, meet with supplier agent, define use cases, blah blah blah, and again these requirements and design model we'll discuss in upcoming lectures. So this is all the planning is being done over here till coding, perform tests, and so on. Eventually software will be released. Okay, so this is work breakdown structure. So these structures are being developed. Iterations will be defined. If you are implementing Scrum, then sprint will be defined for how long the sprint would be, what requirements would be considered and which iteration or sprint, and so on. So a lot of planning is going on. Now teams are working. So analysis will be started, analysis in which we need to understand the requirements, what are the requirements, what functionality client wants. So we need to start developing them in incremental fashion. And these are the requirement models. In your first assignment, you will be developing requirement models, the analysis part of your assignment. And use case diagram, domain model, class diagram, these are requirements model, okay? And we will build them in iterations. So you continue with those models, and then you will start with certain design elements as well. Okay, these are again certain requirement models, and you may come up with certain design models. That, okay, these are the components. This will be the software architecture, and so on. So now this is day 3. So you see that we started with day 1. Pre-planning involves a lot of stuff, but as soon as we started day one, we basically identify what portion of the software that we need to release in 2 weeks' time. And we start working on that analysis for that piece of code, for that increment, and so on. Okay. So for that, again, to release an increment, customer has to use that software. So it should have certain interface as well. So you can also define certain interfaces as well, so that when increment is released, you can, so clients can use it. Database is again an important integral part of software system. So database modeling, what tables should be in the database, what sort of information should be saved in the database, how software will interact with the database. Database would be on same server or remote server. If remote server, how it will communicate with them. So all these things are discussed. Now this is a design part. We are talking about a solution over here. So previously there was some analysis part, now design part. Again, for that piece of release, that increment that we have to do. So this is architecture diagram. Okay, so architecture diagram is the skeleton of the system. So okay, so we have 2 information systems, the supplier and product information system. They are subsystem of trade show system. So we are going to develop trade show system that consists of 2 subsystems, A and B. Now those systems will be deployed on one machine. They will have a database they will access, and that server will be internal to the organization. So this is physical infrastructure we are talking about over here. And through internet, through browser application, they can access this software. This is the architecture diagram that tells us where components or subsystems would be residing, where they will be residing, what would be the client machine, what would be the on servers, and where servers will be located. So all this comes under architecture diagram. This is not software architecture, this is architecture of the system. In system, we have these database servers as well. Software architecture would be over here. This trade show would have a software architecture. This supply information system would have its own skeleton. Similarly, product information system would have its own skeleton. Okay, but this is the overall system architecture diagram. And this is details of that architecture diagram, that within this supply subsystem, we have 2 subsystems further. One is, we can say 2 modules, which is view layer and domain layer, and these are the classes within those modules that implement the functionality. Okay. So this is day 4 going on. We started very rapidly, we identified some requirements, and we started analysis and design. And after day 4, in day 5, we started coding as well. Okay, so for that increment, we started coding, and we did the required coding that could be released as increment. Okay, and we will build it, test it. If there's certain integration involved, we will do it, and we will eventually go for testing of that software. Okay, and testing, what we do, we basically create certain test data. Test data is the data which we will give to the software and see what is the outcome. If outcome is what we expected, test cases will pass. So this is how we conduct them. For example, we have test data, we conduct the test, we instantiate the software, we provide the input, we see what are the errors. If error comes, we note them. If there's no errors, we look at logical errors, whether the output is right or wrong, we note that, and we basically generate a ticket for fixing those errors to the developers. They will fix it, we test it again, test again. Once tests are successful, it will result of end of testing phase, and that software would be ready for release of first increment. So this is how quickly things are done when we go for agile development. There's no lot of planning involved. Planning is just to develop a software that we can do in a week or in 2 weeks' time. So in day 6, we have a piece of software for them to use. It's not a complete software, but it has something that client can start working on it. Because once client gets something to work on, then he can better brainstorm. Then he can come back to you, oh, don't do this. I got a better idea now to start doing this. Because you have spent 2 months, a week on it, you can maneuver around. It will not be costly. But if imagine you have spent 6 months, you release the software, and the clients by looking at the software, we have done it wrong. We should have done in this fashion. Then it is very costly operation because you have spent 6 months on it, and now you are saying that everything is of no use. So that's why agile methodologies are good. So agile methodologies, as we discussed, is good when project is small and medium because communication is the key. You are communicating a lot and delivering the project. What about bigger projects? Can we use these agile methodologies for the bigger project? Can we use the increment in 2 weeks' time? So there's a big question over here. So that's why these two terminologies are used: scaling up agile methods and scaling out agile methods. When we say scaling up agile methods, basically we have a big project, very long going project. Now we have to improve the Scrum methodology, Kanban methodology, extreme programming methodology so that we can apply it on big project. Because teams are distributed and the software is quite complex. Now instead of having sprint for 1 week, we can have maybe 1 month sprint. And we may need more planning over here. Rather than 1 sprint meeting, we need maybe 2 sprint meetings, 3 sprint meetings, and so on. So you have to scale up according to requirements of the project. Scaling out is, there's an organization who has been doing software development for many years. Now how that organization can apply this agile methodologies, keeping in view these are the things which agile basically software are at the core of the software. So in scaling up, we are looking at the project and how we can use these methodologies by improving them, and scaling out, okay, this organization has to change. So it has to be more agile, how they can do it. So there are many issues in there that organizations need to address. For example, these contracts are only signed when requirements are outlined. So the vision document. If you can outline in vision document these are requirements, then definitely things will be signed. But if the project are very big, then these contracts are very difficult to go with because the requirements are not much in there. They are very vague, and client may not be in a position to sign the contract. So there is risk involved on both sides. It might be possible that after a couple of months they need to change the direction. So this is one challenge when we go scaling out of these agile methods. Agile methods are most appropriate for new software, but about software maintenance. In new software, because we have to interact with the customer, communications involved, we can do it. What if we have developed software using agile methodology? Now a couple of people have left, and they didn't do the documentation because it was all through communication. It was a small team. And the new person came into the team and he basically made that change. And it may result in a ripple effect. So this is another challenge. And mostly these agile methods are designed, the teams are co-located, maybe in same room. Okay, they can talk to each other. Okay, we are doing this, where you have reached, and so on. But if they are distributed, then again, we need to scale up these agile methodologies. Okay, so these are the things which organizations are doing. And there are projects for which agile methodologies are being scaled up to give them required results. That's it for today. So that was about agile software engineering. Any questions? I think this is good. Okay. So tutorials of the workshop is available. Okay, go through it, and in your tutorials, your TA or myself, I will interact with you for group formation, and we will follow that brief and start working on your workshop and so on. And again, if you have any question which is of general nature, post it on discussion board. Otherwise, you can drop me an email as well. Take care. Thank you very much. Yes.
For the tutorials and the workshops, do we have to install any of the software?
Not right now, but we will let you know very soon. Okay. Yeah. provide you information. Visual paradigm we'll be using from week 4 or 5. Yeah. But we'll let you know. Okay. So have you used any software before? Have you used any software before? For modeling?
Master,
Oh,
I've been using other technology, but not using it.
okay.
Always using GitHub and
Okay, that's good. I was going to ask. So did you read this course representative description? What's the process? I need to notify them about you. Okay. And what else I need to do? I need to do. Okay. No worries. Yep. No worries. Thank you. Yep.
I sent you an email. Have you said today?
Sorry, I can't hear you. You as well, you are also masters?
Yeah, yeah.
Okay, so you are two. Okay, so I need to decide one of them. Yep. About what? Undergraduate? No, sir. You are also master. So I got 3 emails. I think all 3 of you from masters. So I will make decision by this weekend. So I will look at what you have sent me. If there's something that distinction you out, I will select you. If there's nothing, then I will do 1, 2, 3 and select you. So, but I need from undergraduate. I think no one undergraduate has. But anyways, I will get back to you. Okay.
Like I saw the speak figure of the mentor is like B including A, C including B, right?
Yeah, you can see that. Don't think including is inside. It's a communication, coupling. Think as a coupling. This could be A and B talking to each other.
So like they have some ways to cross together, but they have
But don't think like in this fashion that it's engulfed.
like two like this 2 circle and they have one path together, right?
Not necessary. They may be A and B, and they just talk to each other. It's not mandatory they have something. So it's a good point you raised, the way it has been constructed.
Yes.
But it's all about increment. We start with some functionality, which is products, features. Then we added another functionality, which is payment. Then we added another functionality. It is not structured the way you are thinking. These are 3 components separate, talking to each other.
For example, like this, products, shopping, and payment, they are like for A and B, product in shopping cart. So product is in the shopping cart, right?
No, that's what I'm saying. This is misleading the way it is being captured, and I didn't realize it. But you can think of this like. How's the marking?
Here. Oh.
But anyways, these are 3 separate. No. So this is module A, this is module B, and this is C. So we developed this module. Now this is a system, okay, ABC system.
Yes.
So we release this, and this is over here. Client can use it.
Oh.
Okay. So then we release another ABC system. This is module 1. This is module 2. A, B. They are talking to each other.
Yes.
Client can
Is
use
it
it.
Directive.
Yep. And this is an ABC system. A, B, C. A, B, C.
They interact to each other.
Yeah. So this is how. Maybe I will change the diagram, but this is how they interact with each other.
Okay.
So they physically, it's not like that engulfing and so on.
Yes. And
Okay.
I want to like continue my
You
first.
keep this?
Oh, thank you. And the first question, the standard to the number of the cohesion and cohesion and
What you do, just drop.
like in a company, do they have maybe a manager or the customer has a number like 20 coupling?
Okay, so what you do, if you go on Canvas website, I have one discussion board over there, topic related questions. Go on Canvas site.
Or Canvas?
Canvas, yeah. Go to discussion forums,
And to
topic related Q&A. Just drop this question over here. I will reply and attach some information which I have.
okay.
Okay, and other people can benefit
Okay,
from
I
that.
think it's a good idea.
Yeah, okay.
I will review.
Thank you. Anything else?
Thank you. Have a good day.
You too.
Take care.
Oh, yes. systems?
Yeah.
Yeah, that's the one. Renewable energy systems, is that right? For the tutorial? No, not signal and system.